All right, so for the density and specific gravity of 1106 lab, what we're going to do here, we're going to work on first the density of water. We got our 50 milliliter graduated cylinder right here, as you can see. We got our beaker. We're going to use a smaller one. I don't think we need a big, massive one. And then we got our water. Okay, so then what we're going to do is first they ask us to measure out about 20 milliliters of water. And then once we measure out the 20 milliliters of water, we got to get the mass of the beaker by itself, and it's dry. Once we get the mass and we have the volume already recorded, we're going to now place the volume of water that we have in the graduated cylinder into the beaker, and then we get the mass again. What we're really after is the mass of the water by itself. And then we're going to calculate the density. Okay, so let's go ahead and do that first. We're going to record an amount of water that we're going to add into our graduated cylinder. And so let's see if we can get it around 20. That's a little crooked. And so here, as I'm gonna move the camera so that you can get a better view of the mass, and we are at about 20 milliliters, okay? And so as you can see, and as we are recording, it's about 20 milliliters, so that's where we want to be. And then the next thing that we're going to do, whoops, all over the place here. We're going to go ahead and turn on our scale. And once we turn on our scale, all right, now we're going to get the mass of our beaker. And so here we have our beaker, and we're going to get the mass of it. Try to get it as centered as possible. And as you can see, the mass of the beaker is going to be approximately 30 grams. Okay, or it's fluctuating. Okay, so 29, oh, it keeps moving. Oh, don't move on me. 29.96, we're gonna remove it before it moves again. So 29.96 would be the mass. And then now what we're gonna do is we're gonna now transfer the volume of water into our beaker, and hopefully we get all of the water transferred, right? That's our hope. And so now we get our beaker, and we're gonna zero it out. And as we zero out our scale, we're gonna place the beaker on there again, and we have a mass of 50.8685. And so that's the final mass after we added the water. So then what we're going to do is we're going to subtract that mass minus the 30 grams, and that'll give us our mass of our water. Okay, so then now our job is to determine the and calculate the density. Okay, so the next thing we're going to do is A2, which is the density of an unknown liquid. So here we got an unknown liquid, which I've already just put into our beaker. And so what we're going to do is we're going to place about 20 milliliters of the unknown beaker into the graduated cylinder. And then again, we're going to weigh a small dry beaker. Okay, we're going to get the mass of it. We're going to do the same process that we just did with the water. And we're going to determine and calculate the density of this unknown liquid. Okay, and so then we're going to go ahead and pour in . And as we get closer to 20, we'll start adding dropwise or using a pipette, just so that we can get a little bit closer to the measurement of 20 milliliters. Doing so. should be good about there. So now let me go ahead and get you closer to the idea. Right? Zoom it in. Get you at eye level. 20 milliliters. Okay. And then now what we're going to do is we're going to dispense of that volume into our scale over here. Not into our scale, into our empty beaker. But first we got to get the mass of the beaker. And so let's go ahead and wait for this. We're going to zero it out. We're going to place our beaker onto the scale. We got 28.9. Okay. And then we're going to take our beaker out. Make sure you write it down. 28.9. We're going to transfer our volume of our unknown liquid onto the beaker. We're going to get the mass again. Man, this scale is giving me grief today. Zero it out. Perfect. Now we're going to get the mass of the liquid. And we get 45.8. Okay. So then you're going to subtract the initial. Subtract the final minus the initial. And then to determine the mass. And then, of course, you're going to divide that by 20 milliliters. And that'll give you the density. Okay, so now for the density of a solid, so what we're going to do is we're going to determine the density of this cylinder, and we're going to determine based on its densities to see if we can determine which material it's made from. And so what we're going to do first, we got to get the mass of the cylinder, so we're going to use our scale. So as we go over here, we're going to wait for our scale to turn on. And then once it turns on, we're going to go ahead and place our cylinder in the middle. And as you can see, the mass of our cylinder is going to be approximately 14.4645. And so now what we're going to do is we're going to tie the string around the cylinder. And as we do so, we're going to measure the volume of the cylinder. There's two ways of doing it. You can use a ruler or you can use water displacement, and in this case we're going to go ahead and use water displacement. Okay, so alright, so the next thing we're going to do is, since we tied up our string, onto the cylinder, and so what we're going to use is we're going to do water displacement to determine the volume of the cylinder. And so let me move all this to the side. And as you can see right here, the volume that we currently have initially is we're going to still start off with those 20 milliliters and see if it's actually sufficient for those 20 milliliters that we need. Okay. First, the way you got to determine whether it's enough volume is you got to make sure that the volume that you use is definitely higher than the object that you're gonna submerge the water into. Okay, and if you notice, the volume is a lot higher than the object that you're gonna be submerging in there. And so now the thing that we don't want to do is we don't want to splash, and so that's the reason why we tied the string on top. Okay, and so as we slowly but surely let it drop, we don't want any splash happening. And as we submerge it, you'll notice that the volume rose. And so since the volume rose, now you're going to determine the new volume, which is the final volume. And so hopefully you can make your reading right there. And as you determine the final volume, to determine the volume of the cylinder, you're going to subtract the final volume minus the initial volume, and that'll give you the volume of the actual cylinder. And that's how, once you have your volume, we have the mass, and so you're going to divide the mass by the volume that we just determined, and then you can calculate the density, and so you can determine the material the object is made from.
So what we're going to do for part D, for the density and specific gravity, what we're going to do is we're going to measure out a certain amount of volume onto a graduated cylinder, and as you can see, I've given the amount to be approximately 20 milliliters, as you can see, hopefully right there. And so what we're going to do is now we're going to get the mass, so we're going to turn on our scale. And as we turn on our scale, we're going to get the mass of the graduated cylinder and the water, and it's 92.95. And then what we're going to do now is we're going to add pennies. Okay, now we're going to add them in sets of 3. And what we're trying to do is we're trying to find the relationship between mass and volume. And so as we add these pennies into the graduated cylinder, we got to make sure that there is the least amount of splatter. So what we're going to do is we're going to see, we're going to kind of slide them in through the side. In doing so, give me 1 second. And so as we slide them in into our beaker, into our graduated cylinder, we can do it one at a time. And so now we're going to get the mass again. And as you can see, the mass increased to 100.31, or yeah, 31. You're going to take it out. You're going to get the next set of pennies. Before you do that, you got to record the volume. So let's record the volume. And so the volume was displaced to about, I would say, 21 and a half, or actually just 21, to be honest. 21. So let's go ahead and do our second addition of the next 3 pennies, okay? So we're gonna add our next 3 pennies. So we already have 3 pennies in there at a volume of about 21 milliliters, and we got our mass of approximately, I think it was 100.31. So we're gonna add our next set of pennies. And so as we add it, we're gonna put it on our scale. And then our scale reads to be 107.71. We're going to take out our graduated cylinder so that we can record the mass of the next 3. And if you notice, the mass went up to, the volume went up to about 22 milliliters. So then we're going to do our third addition of the next 3 pennies. So far we have 6 pennies in there. And so we're going to add 3 more. So now we're going to add our next 3 pennies. So we're about to have 9 pennies inside this graduated cylinder. So we add 1, 2, 3, and so we kind of arrange it. We get the mass, and now we have the mass to be about 115.17. We're going to get the graduated cylinder off the scale. We're going to record the mass, and we notice that the mass went up to about 23. Right here, hopefully you can see. We're at about 23 milliliters. And so we're going to do our last addition of the final 3 pennies. So far we have 9 pennies in there. Our last addition, so we'll have a total of 12 pennies in there. So we're going to get, do our first penny in there, second penny, third penny, and then we're going to get the mass. The mass of our 12 pennies are going to be 125.58 grams, and then we're gonna now determine the volume. And as you can see, the volume went up to approximately, what is that, 24.5. Okay, all right, and that's it. Remember, 12 pennies in there. Now all you gotta do is graph.